Let's take a look at the process flow diagram for toPSAil. This is for version 1.0.0, which is the version that's described in this paper. And we're currently working on adding more features and releasing the new versions, including capabilities to simulate temperature vacuum swing assorption processes, as well as the layered bed assorption modeling capabilities. So suppose there's a feed available in certain source, right? Such as some reservoir of natural gas, like hydraulic fracturing, for instance. So you have some feed available at certain pressure and temperature. So the feed might not be at a high enough pressure, right, for our separations to happen, because ideally you want to run your separation at a higher pressure. So sometimes you might need to compress the feed using this compressor. That requires a work. Sometimes the feed temperature might be too low or too high than the temperature that we want to carry out this assorption process. So you need to exchange some heat to account for the temperature, right, to get the right temperature of your feed, right? And then we have this mass flow controller that monitors, that get the information about the current pressure level in the feed tank, and then controls the flow to maintain the pressure inside the feed tank at a fixed pressure, which we're naming PF. So this pressure feed tank pressure is the highest pressure ever that's going to happen in this entire network of PSA system, right? Because this is only going to reduce, the pressure will only reduce when you transport the material through different types of valves, right? So valve 6, three-way valves, it's controlled, so either the flow can go to the top or to the right. Let's consider a case where the flow is diverted to the right first. In valve 4, this flow coming from valve 6 gets combined with other valves, and then it gets fed into the assorption column through valve 2, right? Either for the first assorption column or the second assorption column. So always, the feed coming into the assorption column will be through valve 2. When you look at valve 4, they're connecting the bottom ends of the two assorption columns, which means we're allowing these two columns to equalize in their pressures, right? And valve 6 is just, having these materials from different assorption column to come out, and then goes through the pump, and then it basically either it gets thrown away or gets compressed again and collected in the extract product tank. One nice thing about this valve nomenclature is that these valves associated with the bottom ends of the columns are even numbers, and you notice the valve associated with the top ends of the columns are the odd numbers. So going back to this extract product tank, we can collect the extract product, and of course there's the check valve for the extract tank. And then we can actually use extract tank to do different things, right? You can either divert the flow to the top end of the column or the bottom end. So when we divert the flow to the bottom end, and it goes back to valve 4, and it gets mixed with other streams, and then it goes back to the assorption column, the bottom end again through valve 2s, right? So basically that's, and then if the valve extract product gets diverted to the top end, it goes through valve 5, it gets combined with whichever flows, and it gets fed into valve 5. That's important, valve 5, right? Because whenever material is going into the assorption column from the top end, it is going through valve 5. And you can kind of see, going back to this case, valve 6, when the flow from the feed tank is diverted and it's going to the top, it gets fed into this valve 5 again, right? So there's mixing point. So it gets fed into valve 5 and then goes across valve 5 and gets fed into the assorption columns. So just flow into the assorption column from the top end is always through valve 5s. And you can see similarity valve 3, right? It's the equalization between these two columns, but from the top end. Valve 1 basically are the product coming out from each of these assorption columns, which gets combined and which can be actually thrown away if for some reason we don't need the product, or just to bend the system for safety reasons. But typically those products will get collected inside the raffinate tank, which we can actually further remove those raffinate products through this check valve, or this RapidNet product can be used to get fed into var5, pass through var5 and get fed into assertion columns. And remember those cases where we use RapidNet product to repressurize these columns or purge the system, right? So those are all the possibilities that are accounted for in this rather complex looking pressure flow diagrams, but they are, I mean, this diagram is pretty intuitive once you really sit down and think about what's going on.